Hello friends, thank you for checking into this video and I hope it will help you in understanding the topic better. In this presentation, I am going to share with you what is a thermal inversion. To begin with, thermal inversion is an atmospheric phenomenon associated with change in temperature. Okay, so thermal inversion takes place in the troposphere, which is the lower layer of the atmosphere. And to understand about thermal inversion, first we have to have an idea of how temperature is distributed in the atmosphere under an ideal climatic condition. Okay, so under this ideal climatic condition, what happened? The solar radiation emitted from the sun will strike the Earth's surface, and during the process, some of the solar radiation is absorbed by the Earth's surface and some will be reflected back into the atmosphere. And as a result, the surface of the Earth will be warmer, whereas with increase in height, the air becomes or gets colder. Okay, that is, temperature decrease with increase in altitude. Okay, so in addition, now warm air from the surface of the earth rises up and get mixed up with the cold air. Okay, now with the cold air in the upper layer of the troposphere. Now in addition to this, now several anthropogenic activities such as basically burning of fossil fuels by industries and vehicular emission, these have resulted into the injection of huge amount of air pollutant and greenhouse gas into the upper layer of the troposphere. Okay, so now the air pollutant released from various anthropogenic activities also rises up and get mixed up or diluted and are dispersed into the atmosphere, dispersed into the upper layer of the troposphere. Okay, so this condition can be exactly compared with an example of warming a water in a container for some times, where the base of the container or the base of the container with water represent the surface of the earth, and the upper part of the container of the water in the container represent the upper layer of the troposphere. And like bubbles which rises up, the air pollutant rises and get diluted and dispersed into the atmosphere. Okay, so this is how the temperature is under an ideal condition. Now, before that, have a look at this. This is what happened during ideal condition, you see? All right. Now, let's see what happened during thermal inversion. Okay. And during thermal inversion, the relationship between temperature of the air and altitude is opposite to that during ideal condition. Okay. So that is, the air at the surface of the earth is colder, but air temperature increases with increase in height. See, initially during ideal condition, here it's warmer, there is, as you go up, it's becoming colder. But in thermal inversion, the air at the surface of the earth is colder, whereas the air temperature increase with increasing in height. Okay, so the temperature of the air opposite to is the temperature of the air is opposite to that of the during ideal condition, and the temperature is found to be inverted. So therefore, this phenomenon is known as a thermal inversion. Okay, so now the atmospheric phenomenon during thermal inversion is exactly like heating a water using immersion rod. Okay, now for example, you have come across this way, I believe, isn't it? So you want to take a bath, and then you fill up your bucket, and then you put an immersion rod. Let's say you insert your immersion rod into the bucket, and let's say your immersion rod is just half. Okay, it's suspended just halfway to the bucket. And now after half an hour, you'll find that if you go and check your water, you'll find that the water is boiling. Okay, at the lay from the water will no matter how the water where immersion rod, okay, where the immersion rod can reach, will get heated, but not the water below, isn't it? This is very here come. So now the cold water below is trapped by the hot water above. You see, now this is actually the perfect example of what happened during thermal inversion. And to understand that, I like to uh, share with you what is happening inside the bucket. Okay, let's see. Inside the bucket. Now you'll find now that the layer of hot air which is above is above compared to that of the cold water. And there's no matter how much you boil it, now the cold water will not mix with the warm water. Okay, because cold water is denser, so it's below, and hot water is on top, so there's no way that the which is lighter, there's no way you will go and mix up down. Okay, so there's no mixing. And the reason why the cold water remains cold is because there's no heat transfer from the cold, hot region, which is above, to that of the cold region, which is below. Okay. And since there is no transfer of heat, there's no mixings, what happened to the lower layer of the water, the cold region? The water becomes stable. Okay. And now and also the water molecules in the cold region, okay, with the lower part of the bucket are trapped and they're prevented from mixing. That's why it behaves that. So if you look at to this inside what's happening inside the bucket and compare it with that of the atmospheric condition during thermal inversion, you'll find it's exactly the same. Okay, so during thermal inversion, you'll find that the hot air layer is enveloping the cold air, just like that in the bucket, and there's no vertical mixing due to there because there's no wind. Okay, there's no mixing between the cold air and the hot air because there's no wind to mix it, and also there's no sunlight or because the area or because there's no sunlight, or maybe it's especially during the winter season where the sunlight duration is for a very short period of time, and the night is for a long duration period of time, and it is cold throughout the night. So when there's no sunlight, inversion also takes place. And when there is no mixing and there's no sunlight, and when the hot air envelope the cold air, then the temperature in the atmosphere in the atmosphere is in the troposphere is very stable. Okay, and even the air pollutants also are being trapped and they cannot move down. Okay, so as a result, have a look here. So this is what happened, and this is what happened during an inversion. Okay, for inversion, during a thermal inversion, hot air covers the envelope the cold air. There's no wind and there's no sunlight, and the climatic condition is stable, and the pollutant are trapped. Okay, so this is the similarity with what example I just showed you about the bucket water using immersion rod. Now see, during thermal inversion, whatever the pollutant has emitted or whatever the energy that's been released, instead of dispersing like during the under ideal condition, they cannot go out. Instead, they're being trapped. You see. So now with this, we'll come to what are the effects of an thermal inversion. So see, during thermal inversion, the first effect of thermal inversion is because it is the temperature at the surface of the earth, near the surface of the earth, during inversion is very low, isn't it? So what happened now as a result, if rain falls during inversion, what happened now? The rain will have to pass through the water, through the warm air, then it will then pass into the cold layer, and on reaching the Earth's surface, it will fall in the form of a freezing rain. Okay, so this is the first of the primary effect of thermal inversion. Now, since the air near the surface is cold, okay, so what happens next is fog formation is very frequent. Okay, and as a result, if it is retained for a longer period, then due to fog, then there will be a problem of visibility. Okay, and also during thermal inversion, pollutants, as discussed earlier, are trapped. Okay, and since they are trapped, they cannot disperse into the atmosphere. What happened now? They fall back into the surface of the earth, causing smog. Okay, smog, which is a serious air pollutant problem, isn't it? Serious air pollutant. Okay, so with this, I like to say I hope you understand with my discussion today on this topic. And I would like to say thank you so much for listening. And if there's anything that you want me to discuss about or to talk about, please kindly write down in the comments below. Okay. So with this, I would like to say thank you so much and God bless. Thank you.